Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, we're moving right along now. We're in Module 3, Lesson 1. Okay, so this is generating equivalent expressions. So we had an opening exercise when you came into class. I gave everybody a folder. I didn't have any envelopes, so I just put it in folders. And I gave everybody a folder that had quadrilaterals and triangles. So each envelope contains a number of triangles and a number of quadrilaterals. For this exercise, let T represent the number of triangles, and let Q represent the number of quadrilaterals. A says to write an expression using T and Q that represents the total number of sides in your envelope. Explain what the terms in your expression represent. Okay, so I will just bring this in to save some time. Everybody had different shapes, but they had the same amount of shapes. So everyone's answer should be 3t plus 4q. I had placed 3 triangles and 4 quadrilaterals in every folder. The quadrilaterals were different, but the triangles were the same. So triangles have 3 sides, so there will be 3 sides for each triangle in the envelope. This is represented by 3t. 3 sides per triangle. That's what 3t means. Quadrilaterals have 4 sides, so there will be 4 sides for each quadrilateral in the envelope. This is represented by 4q. The total number of sides will be the number of triangles and the number of quadrilateral sides combined together. Okay. So it said write an expression using T and Q that represents the total number of sides in your envelope. So here is your equation, and this explains it. So you have 3 triangles, 3-sided, 3 sides per triangle, and 4 sides per quadrilateral. So there's your equation, and then you solve it. You and your partner have the same number of triangles and quadrilaterals in your envelope. Write an expression that represents the total number of sides that you and your partner have. If possible, write more than one expression to represent this total. So if I was partnering up with somebody and I had 3t plus 4q, then I'd put 3t plus 4q for my portion of the expression. Since everybody has the same number of each, then my partner would also have 3t plus 4q, so I would just say plus 3 more t for triangles, plus 4 more quadrilaterals. 3t plus 4q again. Okay, and it says represent it in more than one way. Then I could say, well, we each had 3t plus 4q's, and there's 2 of us. And then we can distribute that. And that would be 2 times 3t, which is 6t. 2 times 4q is 8. Okay, if I added these up, we can also get 16. Part C says each envelope in the class contains the same number of triangles and quadrilaterals. Write an expression that represents the total number of sides in the room. So, period 1, you have 11 students in your room. So that would be 11 times 3t plus 4q. And then when I distribute, 11 times 3t is 33 triangles. 11 times 4q is plus 44 quadrilaterals. Okay. D says use the given value of t and q of your expression for part A to determine the number of sides that should be found in your envelope. Okay, well, how many sides are in a triangle? 3. And how many sides are in a quadrilateral? 4. So now we're going to just take our equation, 3t plus 33t, plus 44q into our class. Actually, let's do it for individuals first. 3t plus 4q. And if a triangle's got 3 sides, and a quadrilateral has 4 sides, substitute in 3 for t and 4 for q. 3. Okay. 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25. So everybody in the class should have had a total of 25 sides. I was distracted by that bell. Let me do that again. I'm going to make one change. I put 3 triangles in. It's not side, it's how many of them there were. And I only gave you 2 points. So this 16 should be 8. I gave you 4 triangles, not 3 triangles. So that should be 12. Let's do this again. 3t plus 4q. I gave you 4 triangles, and I gave you 2 quadrilaterals on every front. So that's a total of 12 sides from the triangles, and a total of 8 sides from the quadrilateral, totaling 20 sides. So this is the correct question. Okay? There's other ways we can do it. We could have done it such as, no, I guess that's the only way for that. Next step. Okay, use the same values for T and Q and your expression for parts B to determine the number of sides that should be contained in your envelope and your partner's envelope. Fine. Here's where you can have multiple ways. And I'll just do the multiplication in each case. Okay, so it's 2 times 3t plus 4q. I'm going to substitute in how many triangles we got, which was 4. And substitute in the number of quadrilaterals we got, which was 2. Okay, so there's my substitution. T's 4, Q is 2. When I solve this, I have to do what's inside the parentheses first. PEMDAS says to do inside parentheses first, and then within that we have multiplication and addition. So we'll multiply first. 4 times 3 is 12, plus 4 times 2 is 8. Okay, just bring this up over here. And then I do the addition inside first. 12 plus 8 is 20. And there's 2 of us, 20 times 2, and the 2 of us should have 40 sides. F. Use the same values for T and Q, 4 and 2. And your expression from part C to determine the number of sides that should be contained in all of the envelopes. 9. We had 11 students in our class, so all we're changing here is this 2. So we have 11 students with 3t plus 4q. 11 times 3, and t was 4. Plus 4 times q, and q was 2. So when we substitute in the t and the q, we're going to get 11 times 12 plus 8, doing our order of operations. And then we're still going to do inside first. 12 plus 8 is 20, and 11 times 20 is 200. G. What do you notice about the various expressions in parts E and F? What do you notice about expressions from D and F? This is a lot of writing, so I'll just bring it in from the teacher's edition. Okay, so the answer to that is the expressions in part E are all equivalent because they evaluate the same number 40. The expressions in part F are equivalent because they evaluate the same number. This says 240, but in our case, this was an example where they used 12 students. So this should be 220. The expressions themselves all involve the expression 3t plus 4q in different ways. In part E, 3t plus 3t is equivalent to 16. Okay, I didn't show it that way, but we could have done it this way as well. So part E, instead of doing it this way, what they're saying is we could have had 3t plus 4q plus 3t plus 4q is instead of 2 times them. And they're saying 3t plus 3t, this plus this is 6t. And the 4q plus 4q is 8q. That's what they're saying there. There appear to be several relationships among the representations involved: commutative property, associative property, and the distributive property. Okay, example 1. Any order, any group property with addition. Rewrite 5x plus 3x and 5x minus 3x by combining like terms. Write the original expressions and expand each term using addition. What are the new expressions? Okay, so when they say expanded, here's what they mean. Take 5x plus 3x equals 5x means x times x times x times x times x. There's 5 of them, so that's 5x's. Okay. Pluses here, not times. That's a mistake. 5x is x plus x plus x plus x plus x. If I multiply it, I have powers. Plus 3x, x plus x plus x. Here is our representation of 3x expanded. And in order to answer these, I just count 1, 2, 3, 4, 5, 6, 7, 8, 9x. 5x plus 3x is 8x. Okay, now we're going to do the same with the subtraction. 5x minus 3x equals, and represent 5x as 1 plus 2 plus 3 plus 4 plus 5x's. And then I'm going to take 3 of them away. So if I get rid of these 3, I'm left with 2x. So 5x minus 3x is 2x. Okay. B, find the sum of 2x plus 1 and 5x. 2x plus 1. And when we say the word sum, we know it's addition. And the word and is our location of that symbol. So 2x plus 1 was given here. And the sum of this and 5x. That's what the word and tells us, where this operation comes from. So 2x plus 1 plus 5x. I'm going to rearrange this to say 2x plus 5x plus 1. Now notice the 1 does not have an x. This is a coefficient. This is a variable. Coefficient, variable, constant. They're not like terms. 2x plus 5x is 7x plus 1. Okay? There's nothing more I can do with this. I cannot combine these. This is not an x. This is just a number 1. 7x plus 1 is not 8x. 7x plus 1 is just simply 7x plus 1. C. Find the sum of negative 3a plus 2 and 5a minus 3. Negative 3a plus 2. Find the sum. Here's our and 5a minus 3. So this is going to be negative 3a plus 2 plus 5a minus 3. If I wanted to change this to all addition, I would do plus a negative 3. Now I want to rearrange this, so I'd say negative 3a plus 5a plus 2 plus negative 3. I did was rearrange these, so I put like terms together. Negative 3a plus 5a is 2a. And 2 plus a negative 3 is negative 1. So my final answer is 2a minus 1. Okay, this is just simplified. Example 2. Find the product of 2x and 3. Product means to multiply. We use a dot, not x, because x is a variable. So product is multiplying. Or we can use parentheses around the multiplying product. The word and tells us where that goes. So I'm going to take 2x times 3. Okay. I can rearrange this by saying 2 times x times 3, and just move the parentheses. That's the associative. And then I can rearrange this as 3 times x. That's the commutative property of multiplication. Okay. Then I can just simply multiply the 2 times the 3, with my parentheses there, times x. And that will give me 6x. And this here would be associative property of the parentheses. Okay. So this says use any order or any grouping to rewrite equivalent expressions. Okay. So I would just put the numbers together. 3 times 2, x, 6x. I can move the y out to the end. So it would be 4 times 5, y, which is 20, y. And part C, 4 times 2 times z, I could put it in parentheses like this, and then multiply the 8 or the 4 and the 2 and get 8. Okay, here I have an x and I have a y. Think of apples and oranges. We are not going to add 2x to 4y and say that we have 6 apple oranges or 6 or apples. We don't combine the two and make a hybrid. We cannot combine x's and y's. So all I'm going to do is simplify the numerical portion by multiplying, putting the numbers together, putting the variable next to them. So 3 times 2 is 6x plus 4 times 5 is 20y. We cannot add these. X and y are two different things. We cannot add them together. If we had girls and we had boys, and I asked you how many girls and boys do we have, you'd say 6 girls and 20, or 6 boys and 20 girls. You wouldn't say 26 children. I didn't ask how many. I said how many boys, how many girls. So we can't combine them unless we are told that what x and y. Alright, E. Again, group the numbers, the variable outside. Group the numbers, the variable outside. Group the numbers, leave the variable outside. Do the multiplication. 4 times 5. 4 times 2. We have x's, we have y's, we have z's. They are not like terms. They are done. Okay. Alexander says that 3x plus 4y is equivalent to 3 times 4 plus x times y. Because of any order, any grouping. Is he correct, y or y? So he has 3x plus 4y. So what this means is 3 times x and 4 times y. It is not 3 times 4. And it's not x times y. It's addition. It's 3 times x. If I have 3 apples and 4 oranges, I do not say I have 12 apples times oranges. It doesn't make sense. The answer is definitely no. Okay? We cannot move the number across this plus. It's only rearrange if it's all multiples. And one way to prove this is we can plug values in for x and y. Okay, so let x equal a value. Let's just pick anything. How about -2? And let y, how about -3? So then when I plug this in, it'd be 3 times x plus 4 times y. 3 times a -2 is -6, plus 4 times a -3 is -12. Add them, I get -18. If he thinks he's correct and he can do 3 times 4 plus x times y, then 4 times 3 is 12, plus x is -2, y is -3. 12 plus negative times negative is +6. 12 plus 6 is 18. They are not. It's always a way we can check. Choosing a value for x, choose a value for y. Substitute into both. And if the answer is true, you might want to try another one. It could be coincidental. But if they're different on the first try, then look to which questions. Okay, here are some vocabulary words you need to know. Variable, that is the letter that represents a number. A numerical expression, the number expression, and so on and so forth. So I'm not going to read all of these. We'll review those ones. And that's the end of lesson 1 of module 3.